My name is Pierre Gonnetan. I'm the Global Market Manager for 3D Printing at Arkema High Performance Polymers.
And I'm Krysten Minnici. I do our sales and business development for 3D printing in North America.
Arkema is a key player in specialty materials. It's a French company with worldwide activities, with a turnover of about $10 billion and 20,000 employees worldwide. For additive manufacturing, we are actually providing solutions for the three main categories of technologies, which are the UV resins for photocure technologies, powders for powder-bed fusion technologies, and granules for material extrusion.
So at Arkema, we really approach sustainability from two fronts. The first is that we help customers by reducing their carbon emissions. And then recently, we've also had a clear focus in the additive space on minimizing material usage.
We are deeply involved in developing this kind of new solutions. The big announcement that we are making here is about new PA12 powders, Orgasol PA12 powders for powder bed fusion technologies. One of the key challenges in powder bed fusion is actually the cost per part. And to address that, the main contributor is the material recyclability. With the new PA12 powders from Arkema, you are able to reuse 80% up to 90% of the initial powders that you've put inside your job, which means actually reducing the variable cost related to materials by up to 50%, depending on the technology and the nesting of your job. So it's actually about reducing the waste, reducing the cost per part, and in the end, it's also about how to produce beautiful parts. The aesthetics are really amazing with these powders, which are very spherical and which have a very specific particle size distribution.
And on the carbon emission side, Arkema is the largest industrial supplier of polyamide 11. And with that, we're really excited to announce our new carbon footprint for our entire global production. This doesn't apply to just one grade. This is all of our grades. We have a carbon footprint of 1.3 kilograms CO2 equivalent per kilogram. And we've been able to do this by first having a bio-based polymer that comes from castor beans, by having renewable energy sources, and then by also making our processes more efficient. So this is really exciting as customers, especially in the 3D printing space, they're looking more and more for these sustainable materials options. And we're happy that as the largest industrial supplier, we're able to supply PA11 into this space.
Arkema is also addressing the end-of-life concerns related to PA11 and PA12 used powders and used parts, actually. With the Virtucycle program, Arkema is able to collect, to analyze, and to recompose new granules made from scraps of powders used in additive manufacturing processes and bring new granules to life for injection molding, for extrusion, for different markets such as automotive, sports, consumer, etc. So one example of a part using actually bio-based polyamide 11 is this one. So it's made from Canyon, a bicycle company. It's a computer bike mount, which is basically a part where the weight is very important for bicycle. And by addressing this challenge with Forward AM, a partner which is developing the grade, which is called Ultrasynth PA11 carbon fiber. So PA11 with carbon fibers inside. They have been able to simulate and to redesign for additive manufacturing so that the weight of the initial part, which was designed for injection molding, is now 50% less versus the initial design. So it's a way to show that designs for additive manufacturing combined with high performance materials that are also bio-based are able to provide some innovative solutions with an impact for the final customers in sectors like biking, but also for aeronautics, automotive, and many others. One example we want to also showcase is, for instance, this covering part, which is basically from the demo kit from our partner HP, which has developed a grade which is HP 3D HR PA12S, S standing for smooth, and that is enabled actually by using the Orgasol PA12 powders from Arkema. And you can see on the surface of the part, the very smooth surface, the high aesthetic and the perfect finishing of the part, while bringing cost reductions in terms of total cost of ownership for the manufacturers of the parts.
Another PA11 example we have is through our partners at EOS, where you can see here that this is a whiter version. And also you can really notice the fine detail resolution, how small of features we're able to get now with additive manufacturing. It really opens the door to a lot of new application spaces, especially where you need this level of detail.
So first I have to say that Arkema is taking sustainability at a global level very seriously. Arkema is one of the few chemical companies in the world to have signed and received validation from the SBTi for its ambitious decarbonization roadmap with targets for scopes 1, 2, and 3 by 2030, SBTi being the Science-Based Target Initiative. And at the additive manufacturing level, we are taking that also very seriously because we believe that collaboration is a way to make sure that sustainability is taken seriously at each step of the value chain.
And with collaborations in additive manufacturing, because we're a raw material supplier, we work a lot with different partners across the industry space who really help hone in our sustainability messaging and push that through with their customers as well.
To add on that, collaboration, it's also a way to have experts, different perspectives that are enabling Arkema to develop not only high-performing solutions, but also solutions that are highly recyclable, like the materials we talked about previously, to make sure that we align on the circular economic goals that we also have within the company.
Sustainability is really hard to tackle alone, and being part of a broader organization like AMGTA gives us a space to talk to other like-minded companies in additive manufacturing and really figure out together how to tackle these challenges and also figure out what that means for our industry.
It's also a way for us to discuss industry standards at a global level because we will not change the industry on our side, only Arkema, only machine manufacturers, only formulators, only service bureaus. It's something that we have to take very seriously all together to change and to move the change forward.
And with standards, AMGTA is doing a great job in terms of also defining what scope you need to look at for your carbon emissions in different processes. Each additive process is so different, brings different challenges from either the raw materials side, how much energy you're actually using to print, how that varies from country to country. And I think Sherry and the team at AMGTA are really doing a nice job of creating these committees that we can help define what that looks like for polymer bed fusion, what that looks like in the metal processes, and really standardize as an industry how we calculate our carbon emission values.
AM is basically a way to tackle the issue of logistics, which means, of course, produce locally with decentralized production first. It's also a way of reducing waste. You've seen that with the materials that Arkema is also developing, which is about recyclability and reusability for powder bed fusion technologies. But more than that, it's also about how to educate at a global level AM users and AM lovers. It's all about design for additive manufacturing. We've seen one use case where we are reducing the weight to optimize and to have a better efficiency for the part. It's true also in various domains to design the right part with the right specifications for the functionality of the part to make sure that we can engage in energy savings in the life cycle of the part, not only when producing the part, but also when using it. It's true for many end-use markets, such as automotive, energy, aerospace, defense, everywhere. So AM, I'm a truly believer that AM will be used in more and more markets in the future.
And when we talk about design for additive too, I think one important thing to think about is also the part you're not printing. By enabling additive, it's really enabling us to use less material in our prototyping and really focus on parts that can be used in a faster cycle of production.
At Arkema, we are trying to address this issue, and for the AM users or beginners, how to navigate within all the ecosystem, all the materials, all the technologies, and we can direct them to a platform which is an online platform, which is the digital platform Easy3D from Arkema, where they can basically put their requirements in terms of mechanical performance, chemical resistance, number of parts to be produced, and they will get a technical recommendation based on this specific quantitative criteria to select the best material fitting technically for their project, and then being able to get quotes from partners, manufacturing partners that are able to provide quotes and then print parts online. So it's really a journey from A to Z so that the user can really only have a design file and then get a final part.
We want to share a huge thank you with AMGTA and its members for taking part in these conversations. You can watch the series at mansus.co.